Dependency injection is a technique where we delegate instantiation of dependencies to an inversion of control container. In our case, this IOC container is the Nest.js runtime system itself. Nest.js handles all of the heavy lifting here, instead of trying to achieve dependency injection ourselves. Essentially, when we ask for a dependency in a class constructor, Nest.js handles and retrieves the object back to us, along with any dependencies it might require, and so on and so on. Let's take a look at an example in our own code and dive into how it all works. In our coffees controller, when we are using coffee service and injecting it here in our constructor, what exactly is happening in Nest.js under the hood to make all of this work? Well, there are three key steps in the dependency injection process that make it all happen. First, in our coffee service, the injectable decorator declares a class that can be managed by the Nest container. This decorator marks the coffee service class as a provider. Second, if we jump over to our coffees controller, we can see we are requesting the coffee service in our constructor. This request tells Nest to inject the provider into our controller class so that we may be able to utilize it. Lastly, Nest is aware that this class is also a provider because we've included it here in our coffees module, which registers this provider with the Nest inversion of control container. That's how it all works in our code itself, but now let's dive even deeper to see what Nest does. When the Nest container instantiates the coffees controller, it first looks to see if there are any dependencies needed. In our case, there is one, the coffee service. When the Nest container finds the coffee service dependency, it performs a lookup on the coffee service token, which returns the coffee service class. Assuming this provider has a singleton scope, which is the default behavior of injectable providers, Nest will then either create an instance of coffee service, cache it, and return it, or if one is already cached, it will return that existing instance. We are simplifying everything a bit, but hopefully this all helps illustrate the point. Analyzing our codebase for dependencies is quite the complex task that Nest handles for us, and it all happens during application bootstrapping. This dependency analysis, or creating the dependency graph, is transitive. In this example, if the coffee service itself has dependencies, which it does, those dependencies need to be resolved as well. The dependency graph ensures that dependencies are resolved in the correct order, or essentially, that they are resolved from the bottom up. This mechanism relieves the developer from having to manage such complex dependency graphs. Alright, enough theory for now. Let's take a closer look at the module decorator. In our coffees module, we declared coffee service in our providers array. So far, we've supplied all of our providers via a list of class names. But in fact, this syntax is actually a shorthand version of the more complete syntax. Now that we see this explicit construction, we can start to understand the dependency registration process. With this complete syntax, we can see that we are clearly associating the token, coffee service, with the class coffee service. The shorthand notation is merely a convenience to simplify the most common use case, where the token used to request an instance of a class comes by the same name. Later on in this chapter, we'll be looking at other useful ways to provide alternative values and other dependency injection tips and tricks.